All right, folks, I've had a couple of you ask about, this is from section 3.9, question number, it's number 19 from the text. I'm not sure which number it is in my math lab, but if you just look at the nomenclature here, you can figure out which problem it is in the my math lab. So we're asked to take the derivative of the natural log of the absolute value of the sine of x. So let's give this a shot. I had some of you wonder if it was a product rule question, and it is not. So let's just look at why it's not a product rule. So what am I taking the natural log of? I'm taking the natural log of the absolute value of the sine of x. So this is not, I don't have two separate functions that I'm multiplying together here. Remember, ln on its own means nothing. It's not until you take the natural log of something that you actually have a function. And so when I look at this, I only see one factor here, so it's not a product rule. Instead, I have functions nested inside of other functions. Okay, so I'm going to go off of this rule right here. We proved this in class, that the derivative of the natural log of the absolute value of x, we proved in class, was the same as just the derivative of the natural log of x. That is, basically the absolute values made no difference in computing the derivative. Now careful, that's not always true. That's only in this case. Okay, so let's keep that rule in mind. And what I'd like to do is let's just sort of see if we can resolve the notation a little bit. It might make it easier to see where we have functions nested inside of functions. So if I let, first of all, let's give this new function a name. Let's call it h of x is equal to the natural log of the absolute value of the sine of x. Okay. So what I've written there is perfectly fine. I'm going to go ahead and just to help you see the function inside of the function, let's go ahead and write it like that. So I can define an outer function, let's call it f of x, and say that f of x is equal to the natural log of the absolute value of x. And then let's define the inner function, g of x is equal to the sine of x. Okay? So hopefully you can see, if not, let me know, that h of x is equal to f of g of x. So that is, I took the function f of x, and in place of the x right here, I plugged in what g of x is, which is the sine of x. Okay. So that might make it a little bit easier to see that this is a chain rule problem. Well, how do we work the chain rule? Well, remember that we said to take the derivative of a nested function, you first take the derivative of the outside function, leaving the inside function alone, and then multiply that by the derivative of the inside function. Okay. So if we go back up here, we said that f of x was the natural log of x, so that means that f prime of x would be 1 over x. And we said g of x was this function right here, so that would mean that g prime of x is equal to the cosine of x. Okay. So, returning to our problem, what is the derivative of the natural log of an expression? It would be 1 over that expression. So that's where we get the 1 over sine of x. Okay. But then, by the chain rule, we have to multiply by the derivative of that inner expression. So it was the nested expression. It was sine of x. So by the chain rule, we have to multiply by that expression's derivative, which we said was the cosine of x. Okay. So I hope that helps. Here we had, let me change color. Here we had f of x. His derivative was 1 over x. That is, the derivative of the natural log of the absolute value of an expression will just be 1 over whatever that expression is. So here we go. We had, for our original function, we had the natural log of an expression, the natural log of the absolute value of an expression. So we wrote just 1 over that expression. But then by the chain rule, we had to multiply by the derivative of that inner expression. So we multiplied that 1 over the expression by the derivative of the expression, which gives us the cosine of x. Okay, so we're done with the calculus portion of this problem. Now let's just go ahead and clean up the example. This gives us the cosine of x all over the sine of x. I don't really have a problem leaving it there, but it can be simplified by noting that remember that the cotangent of x is 1 over the tangent of x, and the tangent of x is the sine of x divided by the cosine of x. And so if I invert and multiply, I get this identity right here, that what is the cotangent? The cotangent is the same as the cosine of x over sine of x. So I can now take this expression right here and replace it with replace it with the cotangent of x. I hope this was helpful. If not, let me know.